Hello, and a very warm welcome to today's Explainer. It is so good to have you here with us. Today, we are going to unpack a brilliant piece of technology, the Secure Shell Protocol, architecture, and implementation. Let's take our time, settle in, and understand this completely, step by step. Let's quickly review our roadmap for today. We'll start with the basics of SSH, move on to how SSH connects, explore the magic of keys, look at some real-world SSH commands, and finally compare SSH versus Telnet. Nice and straightforward. All right, let's dive right into Section 1, the basics of SSH, demystifying secure remote access. So what exactly is SSH? Well, Secure Shell is a network protocol that we use to securely connect to and manage remote computers over a network. Now, the absolute key phrase here is by encrypting all communication. That is the secret sauce. It ensures every single piece of your data is totally hidden from anyone who might be snooping on the network, giving you complete invisibility. The basic architecture here relies on two main actors. On your end, you have the SSH client, which is typically your personal PC initiating the connection. And on the other side, you have the SSH server, the remote host accepting that connection. This remote host runs a dedicated service, something like OpenSSH, just patiently waiting in the background for an authorized client to reach out and say hello. Now, what's really fascinating is how versatile this tool is. It's not just for a simple secure login. You can execute commands, safely transfer files back and forth, create encrypted tunnels, and even manage network devices. Whether you're dealing with a basic home router or a massive, complex cloud server, SSH is your foundational tool. Moving right along to Section 2, how SSH connects. Let us understand the behind-the-scenes handshake. This initial meeting follows a very precise four-step process. We start with connection establishment, followed smoothly by server authentication. Then comes the absolutely critical key exchange, and finally, user authentication. Let us walk through these steps chronologically so you can really appreciate the elegance of this design. Now, you might be wondering, where exactly on the network does this initial meeting take place? Well, the magic number is 22, specifically TCP port 22. This is the default port where the server patiently waits for the client to knock on the door and initiate that very first connection. And this brilliantly illustrates how trust is built. First, the server actually has to prove its own identity to you using a host key, which prevents any imposters from tricking you. Only after that do both sides securely generate a shared session key. This is a crucial detail because this shared key encrypts the entire session, ensuring complete privacy before you even type a single letter of your username. Which brings us to Section 3, the magic of keys. Let's demystify public key cryptography. I want to pose a question here for us to think about. How do we authenticate securely without ever sending our actual password over the network? Just think about that for a moment. Sending a password, even if it's encrypted, always carries a tiny bit of risk. So how can we prove exactly who we are to the server without handing over the secret? Well, the brilliant answer lies in key pairs. Instead of relying on a single password, we use a pair of keys, a public key and a private key. Think of the public key as an open padlock. You can share this padlock with absolutely anyone, and it gets stored safely on the remote server. The private key, on the other hand, is the actual physical key that stays in your pocket. It is kept completely secret on your own machine. The server holds the lock, and you hold the one and only key that can open it. So when it's time to log in, here is the verification process. The client mathematically proves it owns that private key. The server then verifies this proof using the public padlock it stored earlier. If everything matches up perfectly, access is granted. And the most amazing part of all this? Your secret private key never leaves your machine. It is never transmitted across the network, which means interception is literally impossible. Let's transition to Section 4, real-world SSH commands. Let's take this from theory straight to application. To actually kick this off on your terminal, you simply type the command SSH. You follow that with your username, an @ symbol, and then the IP address or domain of the target machine. So for example, SSH user at 192.168.1.10. It's beautifully logical. You are just specifying who you are and exactly where the system is located. Now, once that secure tunnel is established, it acts as a very sturdy foundation for other powerful tools. You can see here, while the standard SSH command handles secure logins, you also have SCP for secure file copy, perfect for moving files safely between machines. And then there's rsync-e SSH for securely synchronizing entire directories. The beautiful thing is, all of these operate safely and seamlessly inside our encrypted tunnel. Once you are fully authenticated, you have complete administrative control. You could run a command like sudo systemctl restart nginx to reboot a web server, or maybe run a tail command to watch an access log in real time. It is exactly as if you were sitting right there in front of the machine in a freezing, noisy data center, even if you're actually thousands of miles away. Finally, we reach Section 5, SSH versus Telnet, understanding exactly why we evolved. Let us just gently review the primary advantages of SSH. It encrypts all your data in transit, totally prevents any password sniffing, supports incredibly strong key-based authentication, and makes secure remote administration possible. Without it, older protocols left systems terrifyingly vulnerable to anyone who wanted to eavesdrop on the network. When we put SSH and Telnet side by side, the difference is truly stark. SSH provides robust encryption and secure authentication. Telnet, as you can see, provides neither. SSH gives you high data protection, while Telnet offers absolutely none. And this is exactly why Telnet is no longer recommended today. Telnet literally sends everything, including your top-level admin passwords, in plain, easily readable text. That brings us to the end of our explainer today. But before we part ways, I want to leave you with a provocative thought to ponder. With tools this secure and freely available right at our fingertips, can we really afford to leave any network connection unencrypted today? I think the answer is quite clear. Keep securing your systems, protect your data, and always embrace the standard of SSH. Thank you so much for joining me, and I wish you all the very best in your networking journey.